Hello my dear students of grade 10. Today I am going to discuss with you all the 10th lesson of your science textbook, that is chemical bonds. So from learning this lesson you are going to be able to answer certain questions. Why atoms form bonds? And how do they combine and form bonds? What are the type of bonds? And how do they differ when they form bonds? Those are some of the questions that you will be able to answer once we discuss this lesson. Just think of your names. Each person is identified by a name. And this name is written using the 26 alphabets in English. But with those 26 alphabets, we write so many different names, so many different words. Similar to that, if you look at the periodic table, there are 115 elements. And out of those, there are 92 naturally existing elements that you all know. So these elements combine in many different ways, forming millions of compounds with so many different characteristics. So that is what we are trying to understand from this lesson. With that introduction, I will move on to the contents of the lesson, chemical bonds. So under that, we will be discussing ionic bonds and covalent bonds. Those are the two main types of bonds that you need to understand in this lesson. Then the polarity of bonds. When it comes to covalent bonds, there are polar bonds as well as non-polar bonds. So we will relate that under polarity of bonds. Then the intermolecular bonds. So when bonds form, sometimes these are very large structures and sometimes they form very small molecules. But the molecules have to exist together. So for that to happen, there should be intermolecular bonds, bonds between molecules. Then again, the properties of ionic and covalent compounds. So the two main types of bonds, ionic bonds and covalent bonds, they give rise to ionic compounds and covalent compounds. So we will be discussing the properties of those compounds. So with that introduction, I will start the lesson by trying to answer this question. What is the reason why many elements form compounds but not the noble gases? So there are many elements that form compounds but not the noble gases. So you know what noble gases are. We have discussed the periodic table. You know the group 8 elements. They have valency 8 or 0. Why 0? Because they don't form bonds. And we call them as noble gases because they are very, very non-reactive or inactive in nature. So they are there in nature as single atomic gases or what we call as monoatomic gases because they don't react that much and they don't form compounds. Why are they like this? We will try to answer that question using the electronic configuration of some elements. Now look at this table that is given in your textbook. We have the elements here, then we need to write the electronic configuration and the distribution of electrons among the energy levels is shown in the diagram. So first if we take neon, neon has atomic number 10. So you know the electronic configuration, 2, 8. Then take argon. You know the atomic number of argon, 18. So this is 2, 8, 8. Then we take sodium. Sodium has atomic number 11. So what is the electronic configuration? 2, 8 and 1. The same way, if we take chlorine, it has atomic number 17 and the electronic configuration is 2, 8, 7. Now consider the first two elements, neon and argon. So from the number of electrons in the last shell, you know they belong to group 8. So already I told you they are noble gases. They don't form bonds. They exist as monoatomic gases. gases that are formed by just single atoms that do not form compounds. How is that possible? Now, you know their electronic configuration, and you can see in all the energy levels that contain electrons, the maximum number of electrons are present. First energy level 2, second one 8. Here again 2, 8, 8. So when you have 8 in the outermost shell, that electronic configuration is a stable electronic configuration. So because of that, these two elements and these two electronic configurations, so they are stable electronic configurations. Why? Because they have complete shells. They have the maximum number of possible electrons in their shells. So here you can see the third shell also, although it can contain 18 electrons, but you can remember even for potassium and calcium, we fill the shell up to 8 and put the next electron into the fourth energy level. So because of that also you can understand this is also a stable electronic configuration. But look at sodium and chlorine. Now sodium has 1 electron in the last shell and chlorine has 7 electrons in its last shell. So if sodium has to become stable like one of these noble gases, it has to either lose this electron, so that without this 1 electron, it becomes 2 8 electrons, or it can gain 7 electrons so that it becomes a complete shell. The same way, you take chlorine. So here also 2 8 7. So it can take up 1 electron, so the total becomes 8, or it can lose 7 electrons so that the electronic configuration becomes stable. So somehow, these elements, either by losing or gaining electrons or even sharing electrons, they try to achieve this stable electronic configuration or the noble gas electronic configuration. So the stability comes from this complete energy level, stable electronic configuration. So that is what the other elements are trying to achieve. With that, I will move on to the next slide. What are noble gases? So you all know noble gases. Noble gases are elements that belong to group 8 or group 0. You all know that. It's either group 8 or group 0. And they exist as monoatomic gases in nature. And what is the reason? Because they have stable electronic configuration. This is also known as noble gas electronic configuration. So that is how they exist in nature and why they are known as noble gases. So the other elements try to become like noble gases by forming bonds. So as I told you, they can either share electrons or lose and gain or lose or gain electrons. By doing that, they form two types of bonds. So all the other elements try to form bonds in order to achieve this noble gas electronic configuration or the stable electronic configuration. To do that, they need to form bonds, and they form bonds by either losing or gaining electrons or else by sharing electrons. So when they do that, when they form bonds, they have a certain number of electrons that can involve in bonding, and that value is known as valency. You have learned this before as well. So with that, if we move on to this slide where we discuss what valence shell, stable electronic configuration and valency are, you are familiar with this valence shell. The outermost shell of an atom that carries electrons in an atom is known as the valence shell. So outermost shell carrying electrons in an atom of an element is known as its valence shell. So earlier we wrote for sodium and the electronic configuration was 281. So this shell is the valence shell. The same way for chlorine, it was 287. Here again, that is the valence shell. So if it is stable electronic configuration, as I told you before, it has to be a complete shell. So like for helium, neon or argon, the noble gases, they all have stable electronic configuration. Now valency is the combining ability of an atom of an element is known as the valency. So if we take these two elements, here you can see sodium, it's easy for sodium to lose one electron because 1 is a smaller number compared to gaining 7 electrons. So because of that, the valency of sodium becomes 1, that you already know. The same way, even for chlorine, although it has 7 electrons, then losing 7 electrons, it's very easy to gain 1 electron. So this can easily take up 1 electron. So there also 1 is the valency of chlorine. So that is how we discuss the valencies of elements belonging to the periodic table. You all know group 1 to 4, the group number is valency, and group 5 to 8, 8 minus group number becomes the valency. So with that introduction, we will see how these elements form compounds. The attractive forces or binding among the atoms or ions resulted by the rearrangement of electrons in the valence shell for stabilizing the atoms of elements as described above are called chemical bonds. So here there needs to be an attractive force or a binding among the atoms or ions. So for example, if we take hydrogen, 2 hydrogen atoms can combine, now here they are atoms, to form hydrogen molecule. So where you have a hydrogen-hydrogen bond. So this is a bond between atoms. The same way, if you take the atom of element sodium and the atom of element chlorine, they form ions. Sodium gets a charge, chlorine gets a charge. They are known as ions. When atoms of elements have a charge, they are known as ions, because you know when they are in the atomic form, they are electrically neutral. Why? They have the equal number of protons and electrons. Protons are positively charged, electrons are negatively charged. So between ions, there can be an interaction, and that is also a bond. So it can be between atoms or ions. So attractive forces or binding among the atoms or ions resulted by the rearrangement. Now here they are going to share electrons. That is the rearrangement. So sharing. Here sodium lost an electron, or you can say lose and gain electrons. So that is how they get the charges. So rearrangement of electrons in the valence shell for stabilizing the atoms of elements. So once the molecule is formed, the atoms are stable. Even when they form ions, they become stable once they form the ionic bond, giving rise to the ionic compound. According to the way the participating atoms behave when they chemically bind together, the chemical bonds can be divided into two types. So when they share, they are known as covalent bonds. And when they lose and gain electrons and form ions, they form the ionic bonds. So based on that, there are two types: ionic bonds and covalent bonds. So ionic bonds give rise to ionic compounds. And covalent bonds give rise to covalent compounds. So the two main types of bonds and the two main types of compounds based on the bond present. Now we will discuss what ionic bonds are. Ionic bonds. So to understand ionic bonds, first we will look at the electronic configuration of the sodium atom. So electronic configuration of the sodium atom, you all know, is 281. Why? Because sodium has atomic number 11. Now because of this, you all know sodium belongs to group 1 and it is a metal, and metals are usually electropositive. Because they are electropositive, their electronegativity is less. What is electronegativity? The ability of an atom involved in a bond to attract the electrons from the bond towards itself. So usually sodium has less ability to attract the electrons towards itself from a bond. It can easily lose electrons. So electronegativity of sodium element is low. That means it is an electropositive metal. So because of that, it can easily lose electrons. And form ions. Now we will try to understand how these ions form. So now here you can see sodium. This is the sodium element. This is the nucleus. We will fill the electrons in the shells. So the first shell has 2 electrons. The second shell, it has 8 electrons. So when you fill them up, all the electrons are paired, you can see that. And the last shell has just 1 electron. So 2, 8, 1. That's the electronic configuration. In total, there are 11 electrons. So the number of electrons are 11. How many protons are there? It's same as number of electrons. So that is also 11. And the total charge, because there are 11 electrons, there are 11 negative charges. And because there are 11 protons, there are 11 positive charges. So what is the total charge? There is no total charge. It is actually 0. So here students, you can see the electronic configuration of sodium is 281. And because the electronegativity of sodium element is low, it prefers to lose an electron. And that is why we usually call them as electropositive metals, because they have low electronegativity. And they can easily lose electrons and form ions. And this is the atom of a sodium element. So here you can see in this, you know the electronic configuration. There are 2 electrons in the first shell, 8 electrons in the second shell, and only 1 electron in the third shell. So from this, you can see one thing, it is an less electronegative element. Because of that also it can lose electrons easily. And the other thing, there is only 1 electron. So it's very easy to lose 1 electron than to gain 7 electrons. So obviously sodium will prefer to lose an electron and form a positive ion. We will see how that happens in the next slide. Formation of sodium ion. So when that happens, again I will have to fill up the electrons here. You can see. Now they have 8 in the second shell and 1 electron in the valence shell. So that is the valence electron. The one in the valence shell is the valence electron. So that is what is going to be lost. Lose an electron. Then what happens? They have the electrons in the first shell, the 2 electrons, and the second shell has the 8 electrons. So they have 2-8 electronic configuration. If we write that down, now you can see the atom sodium or the sodium atom, the number of electrons is 11 and the electronic configuration is 281. What is the number of protons? The same as electrons, 11. And the total charge is 0 because there are 11 negative charges and 11 positive charges. So the total charge is 0. But when you come to the sodium ion, the number of electrons now has reduced to 10. Why? 2 and 8. It's 10. Electronic configuration is 2, 8. The number of protons still remain the same. That is why we always take the atomic number as number of protons. That doesn't change for an atom of an element or whether it's an atom or in the ionic form. So number of protons is still 11. So now if you look at the charges, there are 10 negative charges, but there are 11 positive charges. So because of that, if you calculate the total charge, minus 10 plus 11, there is a positive charge. 1 positive charge. So that is why when atoms form ions, here you can see sodium atom losing an electron and forming the positive ion. If we write that in words, you can see atom becomes an ion and it loses an electron. Here students, you have to remember, although it is losing an electron, we normally don't write minus electron. It's better to write it as plus electron on the other side. And we give a special name to this ion. This has a positive charge. So this is called a positive ion or a cation. So the sodium ion is a positive ion or cation. Positive ion or cation. Irrespective of the number of charges it has, it can be +1, +2, +3. It doesn't matter. We call them as positive ions or cations. That is how the ionic compound forms. Then if we move on to the next element, we will look at chlorine. Now here you can see the electronic configuration of chlorine atom. So you can remember, students, chlorine has atomic number 17. So the electronic configuration is 287. Now we saw sodium can easily lose an electron. But chlorine is a non-metal and it is highly electronegative. So because of that, it will not like to lose the electron. It will prefer to draw electrons towards itself. So electronegativity of chlorine is high. Because of that, it prefers to take up electrons. It prefers to gain electrons. Is that okay? So the metals, those are electropositive, prefer to lose electrons. Non-metals, which are usually electronegative, they prefer to gain electrons. So if we look at the electronic configuration again. So here we have the chlorine atom. This is the nucleus. The nucleus has 17 protons and there are neutrons as well. We can arrange the electrons here. You know the 2 electrons goes to the first energy level. Then again 8 electrons go to the second energy level. And there are 7 more electrons. So if we fill them up here, you can see there are 7 electrons. If we write the number of electrons and protons, you can see there are 17 electrons, so 17 negative charges. The electronic configuration again is 287. And the number of protons is also 17, so there are positive charges, 17 positive charges. So as you already know, the net charge is 0. Why? minus 17 plus 17. So they are again electrically neutral because they have equal number of protons and electrons. But what happens when they take up an electron? That is when they form ions. Formation of chloride ion. So here you can see, students, there is a change in the name of the ion. If it is a positive ion, we don't change the name. We just refer to the element and say ion. For example, sodium ion, magnesium ion, potassium ion. They all form positive ions. Whereas if it is a negative ion that is going to be formed, that is when atoms take up electrons, then we need to change the name of the negative ion. I will give you all some more examples while we discuss the lesson. So for now, we'll try to understand how chloride ion forms. So you can remember the atomic number of chlorine. We discussed it before, 17. So it has 17 electrons. 287 is the electronic configuration. If we fill the electrons in this atomic structure, you can see this is the nucleus that has the 17 protons as well as neutrons. Here the electrons are filled up. 2 electrons in the first shell. Then there are 8 electrons in the second shell. 8 electrons. And there are 7 electrons in the last shell. You can see 2, 4, 6, 7 electrons in the last shell. 287. So if we fill the number of electrons for chlorine atom, they have 17 electrons. So that means 17 negative charges. Then the electronic configuration, you can see 287. And the number of protons, that is the same as atomic number, that is equal to number of electrons. So number of protons again is 17. So there are 17 positive charges. So what is the total charge of the atom? It's 0. So that means again the chlorine atom is electrically neutral because it has equal number of negatively charged electrons and positively charged protons. But when it forms a bond, what happens there? It gains electrons. So here it is plus 1 electron. In other elements, it can be 2 electrons, 3 electrons. It depends on the valency of the element. So once this gains the electrons, what is going to be the electronic configuration? Again, there are 2 electrons in the first shell. Then there are 8 electrons in the second energy level or the shell. So 2, 8. Earlier we had 7 electrons. Now there is an additional electron that has been obtained. I will use a different color just to denote that additional electron. So now this has 2, 8, 8 electronic configuration. So that means there are 18 electrons. So number of electrons in the chloride, Cl minus is chloride ion. You can see is 18. So there are 18 negative charges. And the electronic configuration 288. It has changed. And number of protons still remain the same. There is no change there, 17. So there are 17 positive charges. When there are 18 minus charges and 17 positive charges, what is the net charge or the total charge? That is going to be minus 1. So because of that, this ion is a negative ion or what we call as anion. If we write the equation for the formation of this ion, you can see the chlorine takes up electrons and becomes Cl minus ion, which is referred to as an anion or negative ion. In this, if we write a common equation, atom takes up an electron and forms an anion or negative ion. So now can you all understand the rearrangement of electrons? In the previous one, sodium had 281. It lost an electron and became 28. So there was a change in the electronic configuration. Here you can see it was 287 in the atom, which became 288. So this has taken up an electron or gained an electron. So there has been a rearrangement of electrons. If you can remember the definition or the explanation for bonds, it said by rearranging the electrons. So that is what happened just now. Sodium lost an electron, chlorine gained an electron. So there was rearrangement of electrons leading to the formation of positive and negative ions or cations and anions. These ions are electrostatic charges and they can attract each other from any direction. Always positive charges attract negative charges. So when they do that, they form the ionic compounds. We will look at that now. Now neutral atoms form positively charged ions by losing electrons. So as examples, we have already seen one ion, that was sodium ion. The same way you can take magnesium, Mg2 plus ions, and even Al3 plus ions. You can see the number of charges varies with the valency. The same way, neutral atoms form negatively charged ions by gaining electrons. So there we can consider chloride ion. The same way we can take oxygen O2 minus. You remember oxygen belongs to group 6. So the valency is 2. It can take up 2 electrons and form O2 minus ion. The same way if we take nitrogen N3 minus nitride ion. So I told you all here the name changes. Chloride, oxide, nitride. And you can see here also the charges change depending on the number of electrons that are gained by the atom. So they form negative ions or anions. And here, there is something else that you need to understand. Now those ions, sodium, magnesium, aluminium ions, chloride, oxide and nitride ions, they have just one atom of an element that has formed the ion. So they are ions of a particular element only. That is one type of ions. Then there are other types of ions which are polyatomic ions, or what you have already learnt as radicals. You all can remember molecules that have a charge are known as polyatomic ions or radicals. So some polyatomic groups too bear positive or negative charges. They are also known as radicals. Another name given for that is radicals. Some examples. You're familiar with these ions. You have learned this in the third lesson as well when we discuss valency and the writing of chemical formulae. We have discussed this. So what is ammonium ion? Can you remember? That is NH4 plus. So a molecule with a charge. What about sulfate ion? That was SO4 2 minus. Then nitrate ion, NO3 minus. Similar to this, you have learned some other ions as well. You can remember chromate ion, CrO4 2 minus. Then bicarbonate ions, HCO3 minus, or even carbonate ion, CO3 2 minus, MnO4 minus, MnO4 minus, permanganate ions. Like this, you all have learned some molecules having charges which are called polyatomic ions or radicals. So not only the ions formed from atoms, even these polyatomic ions have charges. And as you can see, they can have positive or negative charges as well as they can have varying number of charges. So those ions also combine and form ionic compounds by forming ionic bonds. Now we will see what an ion is. So an ion is an atom or a group of atoms with an electrical charge. So an ion is an atom with an electric charge or a group of atoms with an electric charge. Do you all understand that? How atoms form positive or negative ions. So then we will see how these ions combine and form the ionic compound. Now as an example, we will take the formation of the compound sodium chloride. So sodium chloride is an ionic compound. If we write the chemical formulae, it is NaCl. This is, is an empirical formula because there are many ions combined together. So we take the simple ratio between the ions present. So, sodium chloride. If we represent this as a compound, we need to use their ions. You can remember, now this is the sodium ion and that is the chloride ion. So, we have to fill in the electrons. So, in sodium ion, once it formed the positive ion, you can remember electronic configuration was 2, 8. So, there are 2 electrons here and 8 electrons in the valence shell because it had complete valence shell. It achieved the noble gas electronic configuration. You can understand that here. But for this, we have to write a square bracket and we need to indicate the charge there. Always at the right hand top corner of the square brackets, you have to indicate the charge. So, sodium ion. The same way we have the chloride ion here. It gained an electron. So, it got the electronic configuration 2, 8, 8 because 18 electrons. So, 2, then we need to have 8 electrons here. 8, and in the valence shell also there are 8. So, 2, 8, 8. Here also we need to indicate the charges. We need to use square brackets and indicate the charge at the top right hand corner. So, that is your top right hand corner. So, the positively charged sodium ion combines with the negatively charged chloride ion, forming the ionic bond. If we write this, you can see sodium ion forming chloride ion. So, as I told you, there was a rearrangement of electrons. It became 2, 8. This became 2, 8, 8. Now, what does this electronic configuration resemble? You can remember neon has the electronic configuration 2, 8. So, here neon is 2, 8. Sodium ion resembles neon, which is the noble gas. The same way, if you take chloride, 2, 8, 8, that is similar to argon, 2, 8, 8. So, now can you all see? After the rearrangement of electrons, they get the charge because sodium loses and chloride gains an electron. After forming the ions, they get the stable electronic configuration or the noble gas electronic configuration. So, now the atoms of the elements have become ions and have become stable. And they have formed the ionic bond, which leads to the formation of ionic compounds. Is that clear to you all, students? So, now we will see how these ionic compounds form. Now, you have understood how the ions have formed. We will look at the ionic compounds. The bonds form due to the strong electrostatic attraction between the positive and negative ions produced by the exchange of electrons among atoms are known as ionic bonds or electrovalent bonds. Such compounds are called ionic compounds. Now we will try to understand that. Sodium ions and we will have chloride ions. So here you can see chloride ion. I will denote it as a negative ion, whereas the sodium ion we will denote it as positive ion. Now, since these are electrostatic charges or electric charges, positive and negative, and they don't move around, so they are stable, that's why we say electrostatic attraction. So between the cation and the anion, there's going to be electrostatic attraction. And that attraction is known as ionic bond. So here you can see this is the positive ion and the negative ion. Now what happens is there are positive ions arranged in a certain manner. Around these positive ions, the negative ions arrange themselves because all the positive ions can get attracted to all the negative ions. That is, the sodium ions are attracted to the chloride ions. Because of that, they arrange themselves into a three-dimensional array attracting each other. So when there are positive ions like this, the chloride ions arrange themselves around these positive ions. Like this, the chloride ions arrange themselves. Now can you see? Now this is just a two-dimensional structure, a layer of positive and negative ions arranged alternately. And there is electrostatic interaction between all the ions. Now this positive sodium ion is attracted by all these chloride ions. This positive by all these chloride ions. Again, these chloride ions will be attracted by positive ions. That is just in the two-dimensional way. But this happens in a three-dimensional manner. All the ions arrange themselves into a three-dimensional array. So there will be another layer of ions here, another layer of ions. So there will be a negative ion in front and negative ion behind sodium ion. The same way, if you take the chloride negative ion, there will be a positive ion in front and a positive ion at the back. So like that, they arrange themselves into a three-dimensional array. And that is known as the ionic lattice. Ionic lattice. So these ionic lattices are present in ionic compounds. Ionic compounds. In other words, you can say ionic compounds exist as ionic lattices. So the bonds formed due to the strong electrostatic attractions between the positive and negative ions produced by the exchange of electrons among atoms are known as ionic bonds or electrovalent bonds. By losing and gaining of electrons leading to charges. So electrovalent bonds, and such compounds are called ionic compounds. And as I told you, ionic compounds form ionic lattices. With that, I will move on to the next slide where we look at the rearrangement of electrons. So here, electrons in the outermost energy levels of the atoms reorganize during the formation of sodium chloride. So this is again is given in your textbook. We will try to fill in the number of electrons and protons. So before combination, sodium is sodium atom. So how many protons are there? There are 11 protons and 11 electrons having the electronic configuration 281. Again, this is to recall what we have already discussed. Then, chlorine atom has 17 protons and 17 electrons having the electronic configuration 287. Now, I am sure you all also can fill this by yourself without looking. You can think and fill because you have understood how ionic compounds form by the formation of ions. So, after the ion is formed, it becomes Na plus ion, sodium ion. After combination, same number of protons, 11, but only 10 electrons. So, the electronic configuration is 2, 8. And how many protons are there in chloride ion? This should be Cl minus, chloride ion. there are 17 protons, the same as chlorine atom. But the number of electrons become 18, 2, 8, 8. So as I told you before, they have achieved the stable electronic configuration or the noble gas electronic configuration, or you can simply say noble gas configuration. So this is how electrons rearrange themselves or reorganize during the formation of sodium chloride. I am sure you can understand that clearly. With that, I will move on to the next slide. Again, here we discuss about the ionic lattice. I explained this to you all before also, how electrostatic charges, since they are point charges, they arrange themselves into three-dimensional arrays. So the arrangement of ions gives rise to the crystal lattice known as ionic lattice. Why do we say crystal lattice? You have seen sodium chloride at home, the common salt. If you look at the structure, it has a crystalline structure. You know the difference between crystalline and amorphous forms. So the ionic compound sodium chloride has a crystalline structure. Same as that, all the ionic compounds exist in the crystalline form. So the crystal lattice, that is formed by the arrangement of ions. That is why we call it as an ionic lattice. In all ionic compounds, the ions are organized in a three-dimensional lattice. I told you all this before. Now look at this diagram. Can you see the elements? Now here red color is sodium, red is sodium and green is chloride. From the size itself you can identify. Normally students, there are standard colors used to represent atoms. So here standard color as well as the size. You all know sodium ion has only 2 energy levels, whereas chloride ion has 3 energy levels. So sodium is smaller than chloride ion. So this is Na plus and this is Cl minus. So look at this structure, the lattice. Now here there is a sodium ion. This is a sodium ion that is surrounded by 6 chloride ions. Now I explained to you all when there was one sodium in the middle, around that there were 4 chloride ions, and I told you there are many layers like that. Because of that, there will be an ion in front and ion at the back. So here around this sodium, you can see there is one chlorine here, the second one here, the third one here, fourth one here, fifth one here and sixth one here. So all 4 in one plane and one on top, one below. So always around one sodium ion, there are, you can say, around one sodium ion, there are 6 chloride ions. The same goes for chloride ion as well. There is one chloride ion in the middle, there is one on that side, this side, top, bottom, in front and back. So again, around one chloride ion, there are 6 sodium ions. So that is again the ionic lattice. Can you all understand that now? So if you look at this structure also, you should be able to identify that this is an ionic lattice. If you look at this arrangement, here also you can see, look at the ion in the middle, the red color one. Can you see 1, 2, 3, 4, one below and one on top? So there are 6 chloride ions around 1 sodium ion. The same way, around 1 chloride ion, there are 6 sodium ions. But this ratio, 6 ions around 1 positive, 6 chloride ions around 1 sodium, 6 sodium ions around 1 chloride ion, that is a fixed value only for sodium chloride. But for different ionic compounds, there are different arrangements. You don't have to worry about that now. So, as I said, students, around 1 sodium ion, there are 6 chloride ions. There are 6 chloride ions. And around 1 chloride ion, there are 6 sodium ions. So, is that okay? The crystal lattice or the lattice structure, or what we call as the ionic lattice of sodium chloride. Now we will move on to the next slide where we discuss some more ionic compounds. Ionic compounds. So now we will look at some ionic compounds. Mostly the ionic bonds are formed between the positive ions produced by the atoms of low electronegativity and the negative ions formed by the atoms of high electronegativity. So, if you can remember, students, when we discuss the formation of ionic bonds and the ions, I have written examples from the first 3 groups, the metals of the first 3 groups. Sodium, potassium, magnesium, calcium, aluminium, these are metals. They have low electronegativity. So, they usually form the positive ions. At the same time, elements like fluorine, chlorine, they form fluoride ion, chloride ion, then oxygen forms oxide ion, nitrogen forms nitride ion. So, usually group 5, 6 and 7. Those are the electronegative non-metals. So, they form negative ions. So, you can remember these, students, when an less electronegative metals, that is metals of group 1, 2 and 3, combine with the non-metals that are highly electronegative, group 5, 6 and 7. Remember, usually it is an ionic bond. So, you can remember it that way. And here is a table given to you in your textbook. Some ionic compounds are given. You should know their chemical formula. So, the first one is sodium chloride. That is what we discussed before. That is NaCl. Then lithium oxide. So, lithium is Li, and because of the valency, it becomes Li2O. Lithium belongs to group 1, oxygen group 6. So, valency of lithium 1, valency of oxygen 2. When you exchange the valencies, you know the chemical formula becomes Li2O. The same way, if you write for magnesium sulfide, that is MgS. Both have valency 2, magnesium sulfide. Calcium chloride, that is CaCl2. Why? Calcium has valency 2, chlorine has valency 1. So, when you get the compound, it becomes CaCl2. And potassium fluoride, Kf. So, can you all see, students? Lithium, sodium, magnesium, potassium here, calcium, the metals I told you about. And on this side, we have fluorine, chlorine, then oxygen, sulfur. All these form negative ions. So, these are the positive ions and these are the negative ions. So, the less electronegative elements form the positive ions and the high electronegative elements form the negative ions. And the compound formed between these ions are the ionic compounds. So, I am sure you can understand now. With that, I will move on to the next slide, in addition to the above compounds, ionic bonds are formed during the combination of ionic radicals and ions also. So what we discussed before, those are ions of atoms. But here there are some examples where ionic radicals or polyatomic ions are involved. Copper sulfate, you know the chemical formula, CuSO4. So their sulfate is SO4 2 minus. Calcium carbonate, CaCO3. So CO3 minus is a radical carbonate. Ammonium chloride, NH4Cl. NH4 plus is ammonium ion, ammonium chloride. And then ammonium nitrate, NH4NO3. So here both are radicals or polyatomic ions. NH4 plus is ammonium ion and NO3 minus is nitrate ion. Both are polyatomic ions. So here you can see ions of atoms and radicals. Again a radical and a negative ion from an atom, then both are radicals. So like that, different types of ions can combine and form the ionic compounds. Is that clear to you all now? So with that, I will move on to the next slide. There is an assignment given in your textbook. As was done for sodium chloride, illustrate pictorially how ionic bonds are formed in the ionic compounds lithium oxide and calcium chloride. So first we will try to write the ionic compound for lithium oxide. So they only want you to show it pictorially, the ions, lithium ion and the oxide ion, how they combine to form the ionic compounds. To do that, I will start from the basic where we write the electronic configuration. You all know the atomic number of lithium is 3. So by now you all know the first 20 elements of the periodic table, their atomic numbers and the electronic configuration. So this is 2, 1. Now here you can see valency is 2, that's the valence shell electron is 1. So lithium can lose 1 electron. So therefore lithium loses an electron and forms the Li positive ion, lithium ion. At the same time, lithium oxide. So here we need to have oxygen, atomic number 8, 2, 6 is the electronic configuration. This needs 2 electrons. You know the valency of oxygen is 2. So oxygen is also an electronegative element. So that will take up 2 electrons and form O2 minus ions. So again, you all can see clearly, students, lithium loses 1 electron, oxygen needs 2 electrons. So that means there should be 2 lithium ions. So 2 lithium ions will form an ionic compound with 1 oxide ion. That is why we have the chemical formulae Li2O. Is that clear to you all? So that is how we use the valencies. You can remember that Li2O is the chemical formula of lithium oxide. So now if we go to represent them in a pictorial manner, here you can see once lithium loses 1 electron, it has an electronic configuration 2. Whereas oxygen, after gaining 2 electrons, it becomes 2, 8. So then, if we draw the ions, since there are 2 lithium ions that are going to combine with 1 oxygen ion, it will be correct to draw the oxygen ion in the middle and the lithium ions on either side. Here you can see, students, it is the nucleus. Around that we have 2 energy levels or shells, and you know we have to have square brackets. And on this side, I will draw the lithium ion. You all can see the size is smaller because there's only one energy level. Like this, there will be another lithium ion on this side as well. Now, if we fill up the electrons, you can see lithium ion has only 2 electrons in its first energy level and it has a positive charge. This is Li+. Here we have the oxide ion. It has 2 electrons in the first shell and 8 electrons in the second shell. And it has 2 negative charges. And on this side, again we have another lithium ion with 2 electrons in the first energy level only and a positive charge there. So this is O2 minus and this again is Li+. So this is how the lithium oxide ionic bond forms. Lithium ions on either side and oxide is shown in the middle. So to understand that 2 lithium atoms lose 2 electrons and that is taken up by 1 oxygen atom. But you all know ionic compounds exist in the form of ionic lattices. So the electrostatic charges, you can see positive and negative charges arrange themselves in a manner they form a 3-dimensional array of ions, that is the ionic lattice. So that is lithium oxide. Then we have to show the formation of calcium chloride. Is this clear to you all students? So here also you can see all the ions have achieved the noble gas configuration. So the same way we will have to write for calcium chloride. So for calcium chloride, so again we start with the electronic configuration. Atomic number of calcium 20, 2, 8, 8 and 2. So the valency of calcium is 2. It will lose 2 electrons. It's a less electronegative metal. So here calcium atom becomes Ca2 plus ions by losing 2 electrons. At the same time, we have chlorine atom, atomic number 17. So 287 is the electronic configuration. This can take up 1 electron. It is a highly electronegative element. So here 1 chlorine takes up electrons and forms chloride ion. In this, you can see calcium becomes 288. Why? It has lost these 2 electrons. Whereas chlorine has gained 1 electron. So this becomes 288 as well. They both resemble the noble gas argon. You all can see that as well. So again, calcium loses 2 electrons and chlorine gains 1 electron. So there has to be 2 chloride ions formed. So that is why we get the formulae CaCl2. Now you know how you should represent calcium chloride. Calcium has to be in the middle. Chloride ions have to be on either side. So there, if we draw so I will start with chloride ion on this side. The nucleus is there and there are 3 energy levels. You need to have the square brackets. Afterwards, I'll fill up the electrons. Then here calcium ion in the middle. That also has 3 energy levels. We need to have square brackets. And here again chloride ion. So that also needs square brackets. Now we can easily fill up the electrons. So here 2, 8, 8. This is Cl minus. Again 2, 8 and 8, that is Ca2 plus ion. And here we have another chloride, 2, 8 and 8 electrons in the third energy level. So this is Cl minus. What do you need to write now? You have to show the charges. Cl minus, Ca2 plus and Cl minus. So that is how you indicate the ionic bond between calcium ion and two chloride ions. You don't have to use colors, different colors. Here I have used them so that it's more clear to you all. When you draw, you can just use the normal color. Just one color is fine. So that is calcium chloride ion. Can you all understand that clearly, students? So here I will just go back and show you all how we got the lithium oxide. You can see here, lithium loses an electron, oxygen gains 2 electrons. So lithium plus ion and oxygen O2 minus oxide ion. So you represent the ionic compound like this, Li plus O2 minus and Li plus there. Then we have calcium chloride, where calcium loses 2 electrons and chlorine gains 1 electron. So 2 chlorines, 2 negatively charged anions. So the bond, ionic bond between calcium and chloride is represented this way. So with that, students, I have completed the discussion on ionic compounds. We started off the lesson by discussing why atoms prefer to form compounds. You know the answer. In order to achieve the stable noble gas configuration or the stable electronic configuration. They do that by rearranging the electrons. So in an ionic bond, the less electronegative atom loses electrons and forms the cation, whereas the more electronegative atom gains the electron and forms the anion. And the electrostatic interaction between the cation and the anion lead to the formation of ionic bonds. And when ions arrange themselves in a three-dimensional array, they give rise to the crystal lattice that is known as the ionic lattice. And you can remember in sodium chloride, that is the common salt, which is a crystalline structure, in the lattice, there are 6 chloride ions around sodium ion and 6 sodium ions around 1 chloride ion. That is only for sodium chloride. Depending on the types of ionic lattices, the ratio between the positive and negative ions can vary. And also, you know that ions can form from atoms as well as charged molecules, which are known as polyatomic ions or radicals. And the ionic compounds can be formed between ions of atoms or polyatomic ions or a combination of both. So I am sure you have understood how ionic compounds form. So next, in the next chapter, I will be discussing covalent compounds.